well-established teams who racing in, typical road racing stuff, come to Pikes Peak. Their experience are a good team. They've won and it shouldn't be too hard. And they come to the mountain and they just have their arse kicked. And it is an endurance event, but it's not like a car running around for 24 hours. It's like a physical one and a mental one for each and every person on the team. The altitude just compounds that, it just exhausts you.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we've got Robin Shute from the Sendy Club joining us. Now, if you haven't heard either of those names before, Robin is now a 3-time outright winner of the Pikes Peak International Hill Climb, and he just finished cleaning up the competition overall in the 2022 running, which also happens to be the 100th running of this hill climb. Now, that in and of itself may not be particularly special. Obviously, every year someone wins the hill climb, and we've had some pretty big name competitors take out that trophy, including the likes of Sebastian Loeb, backed by Peugeot. We've also had more recently Romain Dumas take out the overall record with the Volkswagen IDR electric hill climb car. The difference, though, is Robin and the Sendy Club are not working with an unlimited chequebook. Essentially, this is a group of enthusiasts, albeit some really smart enthusiasts, who have built and then developed this car over a number of seasons to make it an absolute rocket ship. So this is a very wide-ranging discussion with Robin about his background in motorsport and learning the craft of race driving. We also talk about simulators and their place in motorsport in general, as well as specifically Pikes Peak. Then we dive deep into the development of the Wolf chassis that he's running, the changes that he made from the original 250 horsepower naturally aspirated car to what is now 650 horsepower with around about 2 tons of downforce. Also, of course, diving into the complexities of developing a competitive package for such a unique event given the altitude at Pikes Peak. On top of this, we then dive into his running this year, 2022, where the race day conditions were absolutely abysmal with almost zero visibility, rain, snow, fog, you name it. He still came out and triumphed. Now, before we get into our chat with Robin, for those who are fresh to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people all manner of performance automotive topics. Now, relevant, of course, to today's topic is race driving. And we do have our race driving fundamentals course, which is perfect for anyone out there who's maybe interested in getting involved in track days. Maybe you're interested in starting competitive racing at club level, or maybe you're already racing and you're struggling to find that next step in terms of reducing your lap times. I guarantee this course has something for you, almost irrespective of your skill level. You can check that out at hpacademy.com/courses. We will also put a link to that course in the show notes. And as a listener of the podcast, you can use the coupon code podcast75. That'll get you $75 off your very first HPA course purchase. Again, link in the description. All right, enough with that introduction. Let's get into our chat. All right, welcome to the podcast, Robin. Great to have you along, fresh off, I think, your third back-to-back win at Pikes Peak. Is that correct? Third in a row?
Yeah, hello all. Yes, it is the third one, actually. I did skip 2020's race, so it's the back-to-backs for me, but over on the event I did, there was one in 19 and then 21 and 22.
Okay, either way, you can't be too disappointed winning every time you turn up. I don't imagine too many people can say that they've done that. Before we get into Pikes Peak and particularly the car that you've developed in your racing, let's get a little bit of a background history on who you are and where you've come from. Obviously, the accent gives it away a little bit, British, but tell us how you sort of grew up getting involved in cars and particularly racing cars.
I would say it was pretty much inevitable. My father's hill climbed all my life back in the UK. He was quite a prominent engineer at Lotus Cars, and part of that he was able to borrow leases and a 340R at the weekends to go hill climbing around in the UK. So Shelsley, Walsh, Prescott, places like that. So I've known hill climbing as long as I can remember. And my dad actually still hill climbs more than me. So it's very much in the family. As a kid, I'm just fascinated by mechanical things, and engineering's always has been kind of my natural path. So I started really racing RC cars about age 7, 8. And I ended up kind of racing that nationally as a child and did pretty well in that. I think it was the Kyosho World Cup. And so that gave me a feel for competing, setting up a car, and being sort of mechanically capable. So from there, I did a bit of karting, not a whole load, just clubby, junior Rotax when that really first got going. And yeah, they kind of went to school for engineering, specialized in automotive engineering. Actually, I could do that in the UK. And I didn't continue with motorsport too much, actually. I went into alpine ski racing as like a 17-year-old and carried on with that. Not nowhere near as talented as I am on cars, but enjoyed that all the way through university. It was only when I came back went to the States to work for Tesla Motors, California, that I kind of had a Corvette and took that on track days and kind of got the bug again for motorsport. So that was sort of my early motorsport career.
Okay, a bunch of stuff to unpack there. Just real briefly, I had a brief stint with RC cars back in the day. Didn't really get too deep into them. Obviously, nothing at the level you've done. I'm interested because obviously it is a cheap segue into motorsport, albeit in a slightly different angle. Does the setup and the adjustability on some of the more high-end RC cars actually help you learn how these changes relate on a real car?
Yeah, I'd say actually the low end stuff, as long as you have some adjustability in the car, it carries over. I was 7 years old playing with spring rates, anti-roll bars and gear ratios, all that good stuff. It was perfect. It was a perfect little entry into it. And I was very lucky that my father also knew what he was doing with that stuff, so could explain what was going on with each. So yeah, it was a great first step into motorsport.
Okay, interesting. Now, I'm also a little bit off topic, but you just mentioned Tesla. And is that something you're still involved with Tesla on the day-to-day? And if so, what's your sort of role or responsibilities at Tesla?
No longer at Tesla. I left there a while ago now, probably about 2016, I believe. But I did bounce around a few EV startups. And from Tesla, I went to a startup called Faraday Future. And that was actually where I got my first run at Pikes Peak. And pretty much all the members of the Sendy Club come from Faraday Future. So it was that EV startup world is really got me going at Pikes Peak. So it's pretty significant. Nowadays, I was working on robo race vehicles the last year or so, and now I'm freelancing, consulting, and pulling together motorsport programs for people.
Okay, so it sounds like you've got probably a wider and more rounded knowledge across the whole race and automotive scene than maybe just being a race driver, fair to say? Yeah,
actually, like the race driving thing, I'm probably the lightest on experience with. I've been very lucky that I've had a weird motorsport career development in that I haven't skipped anything at all. I grew up, did a bit of karting, knew how to set up cars. And I've been kind of racing most years of my life, but it was never, going to the National Karting Championship and then Formula Ford, Formula 3, 2, 1, none of that. But I did get the experience. So I think if you look at my driving skill development, it's not missing anything. And in later life, I've done a lot of simulator work and I'm able to use that to improve my driving without loads of seat time. So something I'm very good at is being quick in a car without any seat time in it. And I think hill climb and Pikes Peak is somewhere where you really need that skill and talent.
Yeah, 100%. I mean, we'll get into this in a little bit more detail, but obviously, regardless of the form of motorsport, seat time is expensive. You're consuming parts on the car, burning fuel, tires, etc. It's inevitably expensive. Not to mention the risk of something going wrong and you having an accident. So the simulator, obviously, across all motorsport, has become more prevalent, but yeah, definitely Pikes Peak being such a unique event where you really get that one crack at it, understanding those 156 corners must be absolutely critical. just taking a step back, I mean, karting obviously is the mainstay sort of path for those who want to make it as a career in motorsport, and that these days is becoming increasingly difficult and increasingly expensive to actually get to a point where you're a paid driver and that's your sole responsibility and you can make a somewhat decent living from it. Is that something you aspired to at the start of your experience in motorsport, or was it never really your goal?
I did aspire to it. I was exposed to it, but it was never really an option for me. So yeah, I think nowadays that we actually have a few more choices for career development within motorsport, which is actually a really good thing. It was always interesting watching which kids could go from karting into cars successfully, because great karters would struggle in cars. It's a very different technique and discipline in the way. When you're getting a lot of seat time in cars, typically kids would be pulled out of school to go practice all week round. In the UK, at least, that's how it was when I was there. So you get so well rehearsed and so good at that particular skill in karting that wouldn't always translate into cars. So I don't think it was always a good thing to be fully focused on karting. You need it to develop the neural pathways of controlling a vehicle and stuff at high speed. You need it just for the sense of competition and being an individual athlete, being able to maximize your performance. But in terms of skill and technique of controlling a car, it isn't the everything. And I think you can get a lot out of simulators. You can get a lot out of other forms of just driving vehicles, like bouncing around your back garden in a side by side or something like that. All that stuff I think is valid. And you look at some athletes now, sim racing. You can get very competitive race drivers out of sim racing, and also people like Travis Pastrana, who was never really on that traditional career path through karts and cars, but is very competitive in the vehicle. So I do think there's a lot of different ways you can go about being a very well-rounded driver. It's unfortunately like this FIA pathway of single-seaters and sports cars that has just kind of restricted the imagination of most people. And actually, when you look at where it is now, it's especially in Europe now, I think it's to a fault, and you're getting the same kind of drivers where back in the day you were just getting, I think, maybe more rounded guys who just raced everything because you could back then, whereas now it's too expensive, so you have to focus on one thing.
On that vein, I mean, the way I see it these days with the expensive motorsport at that level, natural talent, obviously, or talent of the driver, natural or otherwise, which we'll get into, is definitely a core aspect. I mean, you're not going to make it if you can't get the car around the track quickly. But at the same time, to get noticed, to get seat time, to get exposure, and to move up the ranks requires cold hard cash and generally lots of it. So what I'm sort of seeing from the sidelines is a lot of drivers now that are at their upper echelon. You've sort of got those who have got that raw talent and are just naturally very, very quick no matter what you put them in. And then maybe some drivers that maybe have got where they've got to, and no doubt they're still very, very fast, but because there's a big checkbook backing them. And I think that's making it harder for some potentially more talented drivers without that financial backing to actually get the exposure and get seen. Do you think there's something to that? I don't see a solution to it if that's the problem, however.
Yeah, it's always been there. Let's be honest, that was the case back in the 90s, 80s, 70s, 60s. What you had back then, in the early days was you had to really want it because you were putting your life on the line to go and do it. And that's although a very small factor now, still a factor. It's definitely not a dominant one. As you go up the ranks, at least you get less and less seat time. Maybe Formula One's a little different, but typically you're driving less and less. So I still think there's an opportunity for talent to come through where you're not over practiced and over rehearsed, and you can be a good driver just by being plugged into a new car and going quick. I mean, everything's kind of coming to a point now where everyone is so good. You look at the Formula One grid now, everyone is really good. Even the bad guys, they're fantastic. And it's just those last little bits. It's the little things that make the difference between being, almost mediocre versus great. The very small things, making good choices in tire strategy or knowing when to push, knowing when to not. Very subtle stuff that makes the difference between world champions and people who never podium. So, that becomes very hard to differentiate the good choices versus a very competitive program to come along with. You look at the lower formula, like for 2 Formula 3, you have to put yourself in a position to succeed, to be able to go and win there. So you need the talent. And I think like talent versus, raw talent versus developed talent is a very interesting topic by itself.
Well, that's actually something I'd like to dive into. I kind of had that on my list. We always hear people talk about drivers who are naturally gifted or naturally talented. And I believe there is some element of that. I've seen people who can jump in a car for the first time and go out and be lapping within a tenth or maybe even faster than the owner that's done 500 laps of their home track. So there's that element of just a natural tendency to understand what the car needs, how to position it, how to control it, versus someone who maybe doesn't get, I don't know if you get born with that skill, but let's say, someone who naturally inherits that sort of skill set and understanding versus learning it. So the question there is, can someone who doesn't have that natural gift to be fast in a car become equally as good with hard work and practice?
I think yes. That's my simple answer. And the reason being, I think these naturally talented guys, they come about from a young age. They've just been exposed to the right feelings, and they get a knack for it early, and then that just continues to develop. And I think it's that it's almost the way your brain works and the way you understand what's going on around you, and you can go and then repeat that. So I'm sure there's natural talents around, like you have faster neurons, or how your body's set up, it does a little better. But I don't think that's the key. You can kind of look at that with drivers and aging. The best drivers are able to keep on going into later years. Lewis Hamilton, Fernando Alonso, their raw pace, I think, suffers as their body ages, but their experience of knowing exactly what to do takes over and keeps them competitive, whereas other drivers start fading.
Sure.
I think there's a bit of it. It's just like physical, and a bit of it of that drive and want and desire to continue to be competitive, and to do that, you need to continue to stress your body and improve it. So I think when it comes back to can you gain natural talent, I think you can, and I think part of that is almost like cross training. So doing a lot of different driving and doing a lot of different things aside from it, mountain biking, all this good stuff. Just really kind of like imagine yourself as a computer. You're programming yourself with lots of different experiences, and you can go and develop that natural talent. I think that the biggest limitation is almost attitude or approach to it. Is you've got to be willing to put in the work to go and create yourself some talent there.
I mean, the old story, regardless of what you want to be good at, is 10,000 hours of experience to reach expert level. And, no big surprises. That goes for race driving just as much as anything else you want to do in your life. So, the hard yards. But unfortunately, that 10,000 hours of seat time comes at a price. Let's move on towards Pikes Peak. Hill climb in general, but Pikes Peak specifically, it's a very unique form of motorsport. What sort of drew you to that? Was this your dad's sort of passion for hill climbing, and you just took it to the biggest extreme there is in the world of hill climbing?
You could say that. I wouldn't say that's actually how I got into it, but I always knew about the event. And I think that shows you my upbringing with my dad. Is I was aware of it from a very young age, and I think that came from him rallying previously, him loving Audi Quattros, and the Audi Quattro was a very iconic car in the late 80s there, and then also being exposed to the Gran Turismo 2 with the Escudo Pikes Peak, and then a little snippet of that, and then all the I guess it's Climb Dance with Ari Vatanen, and just these little clips. This is inspiring, isn't it? Those kind of photos, videos just capture your attention. So I've always been aware of it, and I've always known that's kind of the ultimate of hill climb. Just you could see it right there. You race to the top of a 14,000 foot mountain. It's kind of obvious that's the ultimate. So always been aware of it because it's been gravel that while. And I'm now starting to turn to a bit of a gravel guy, but nowhere near that. I was doing pavement stuff all my life. I never really thought I'd get the chance of doing it, and it slowly became pavement, and then realized, I think it was back in 2014, I was looking if I could take my Pro Mazda up the mountain there. I was looking at the rule set and things like that. So it started to become something that I wanted to go and do, mainly for a challenge in America as well. Like it's one of the big challenges you can do in America, I think, motorsport wise. So that's really neat. And I guess when I first looked at it, I didn't understand why more people weren't doing it, because, the rules are very, very open, and you could kind of take any vehicle up there and go and race it. So back then it was just the logistical challenge of getting there and running the race that was tough. It was a 3-person team at that point, and I don't think that would have been possible with that car. But yeah, it's something I've always been aware of, and knowing that, it's the most extreme of cars and the most extreme of tracks is just awesome.
Now, you just mentioned the rule book, which, and obviously there are different classes, and the rules for some classes are quite specific, but at least in the unlimited class that you're competing in, the rule book, last time I looked through it, to paraphrase, as long as you had 4 wheels, you're good to go. Is that about the extent of your limitations?
Pretty much, yeah. There's some safety rules in there as well for cage and driver kit and things like that, but all good rules to have, and pretty straightforward. There was one rule that was interesting that wasn't unlimited that actually affected us this year a little bit. Was grooving slick tires. There was a rule in there saying you couldn't do that, and they have since changed that this year. That was a live rule change that happened. As wet tire supply turns out to be a global supply issue as well, so people need to groove slicks to be able to have.
So that was changed as a safety element because of the conditions.
Yeah, exactly. And that's the kind of thing of, you want groove tires to be grooved safely to manufacturer spec, which is what the rules now say, but they were trying to just avoid any opportunity for somebody grooving them wrong by basically outlawing it. But it's more safe to have a hand cut slick in the wet than just a slick in the wet. So I think that was good. They changed the rules for that. So
common sense prevailed on the day.
Exactly. Yeah.
Right. So one of the problems I see with such an open rule book is when you've got no limits, what direction do you go in? And it's very easy to sort of go down a path that maybe in hindsight, once you've developed it and spent a huge amount of time and money on it, maybe wasn't the best. So what was your sort of thought process around choosing a car, or was it a case of you had the chassis and thought, well, hey, we've got this, let's go?
It was a pretty methodical process. I come from, a family that was very much into Lotus, and Colin Chapman's keep everything simple and light. It has always been my mantra and way. And my experience was also in open wheel downforce cars as well, so it leaned in on that. You could see at the time Romain Dumas was running a Norma competitively, and he's won 3 times at the mountain with that Norma program, and then the 4th time was in the IDR, of course, afterwards, which is still a Norma underneath. That's a Norma chassis.
Oh, I didn't actually realise that.
Yeah, same car. He sold his tubs to Volkswagen to develop the IDR, basically. So he's now carless. That's why it's one of the reasons why he doesn't come back. So yeah, we kind of knew that my skill and expertise suits this new paved era of Pikes Peak, and at that time it was the Normas Wolves, a CN2 FIA CN2 class car that was just becoming obsolete. So there was a lot of cars on the used market at good prices, and it was a great base to go racing with. The CN2 class was basically a Honda K20 2-seater sports racer with spec engines, 250 horsepower, and good downforce. I picked the Wolf for the simple reason that the tub was kind of laid out like a single seater. So most other cars had a front clip that bolted over the tub, whereas the Wolf had a tub by itself and then extra fenders stuck on the side. So that allowed us to go and pull those fenders off and then kind of run the front open wheel. Basically, I call the car almost like a mullet car. You've got the business in the front, party on the back, sort of deal. And that was there just to allow us to run big tires in the car. And then also give us some freedom around front wings. So how we go and make downforce on the front end of the car, and also save weight, because that was the first focus for us was just keeping the car light.
Yeah, makes sense. We'll talk about the car in a lot more detail, but before we get into it, when you first started developing the car and decided you're going to go run Pikes Peak, was there an expectation of an outright win, or was the car essentially faster than you expected?
No, we always went there to go win. And even when the Volkswagen program was announced, I think it took everyone by surprise how fast that program was. But that year was one of the strongest entries ever. We had Simone Fagioli in his European hill climb winning Norma with extra bells and whistles on it, and you had the IDR, which wasn't really, when they announced that program, they were just aiming for the electric record, which wasn't that fast. And then you had us kind of turning up, trying to pull something together. We had no expectations to go and win, but we were going to win, knowing it would be hard and it would take us probably a couple of years to go and achieve that goal. But we essentially knew what the winning formula was with Romain Dumas's normal program, and actually continued with his exact engines that year, and with the goal of making something faster than him. Yeah.
Okay. Yeah. So you've got a proven package, a proven recipe, essentially. Just take it that little bit further, drive it properly, drive it fast, and you were within reason, somewhat guaranteed at least of a good result. Now, in terms of training for Pikes Peak, well, actually, let's take a step back from that. And I would imagine that everyone listening, unless they've been to Pikes Peak, has no clue about how hectic and how wild running a car for Pikes Peak is, in terms of the practice and then actual race day. And the problem with Pikes Peak is that other than the Sunday, the race day, the mountain is open. It's a toll road, so you can drive to the top, and they open it to the public every day. It's only closed for the race day. So as a competitor during the practice days, you're talking about a 3 or 4 a.m. start. From memory, you had to be on the mountain at 5 a.m. And basically, as soon as the sun's up, you got your practice runs, and then 8:30 sort of packed down because the mountain's open at 9 a.m. Is that my recollection correct? It's a few years since I've been.
Yeah, pretty much spot on. Yeah, I think you would. Yeah, practice finishes at 8:30 a.m. So the last car goes up, and then you've got to be packed off and going at 9. And so you go and run these sections, and once you're done, you turn back down and roll down the road. And so your last run of the day, you'll be rolling down the road with tourists going the other way, school buses, RVs, anything. So it's an odd experience of being, one of the fastest cars in the world and just tourists driving the other way. No clue what this thing is.
In terms of this as well, because you've obviously got a huge number of competitors, everyone needs to get practice runs in, and depending obviously how fast the car is, a full run up the mountain might be sort of 10 minutes plus. So in order to make it practical, they actually split the mountain into 3 sections, and you sort of rotate, correct? So you sort of set up in groups.
That's it. Yeah. So they split the mountain into 3. You got the lower section, which is actually 2 sections combined, which is the qualifying section. And then you got the mid section, which is the W's, the infamous switchbacks. And then the last section, top section, is kind of like a dual-natured beast of first bit being incredibly fast and flowing, some really fun turns, but also some like very high stakes, and you're well into the aero realm, and there's often winds blowing in all different directions, so very hard to judge what your car can do. And the last bit is just some long, bumpy drags and tough corners to go through up to the finish line. So, yeah.
Let's talk about those bumps, because, again, what I'm trying to do is fill in the picture here for the 99.9% of people listening who haven't been there. And when they paved Pikes Peak, I've talked to someone about this, I can't remember who it was, I think it was an official, and essentially when they paved that top section of Pikes Peak, you're at altitude, the peak obviously 14,000 feet, and even in the middle of summer, which it's just been, you've still got snow on the ground around you, and essentially you're not really supposed to pave road at that sort of altitude, because you get the snow melt, the water then runs underneath the tarmac, and then overnight it freezes, and when it freezes obviously water expands, so you get this sort of upheave of the tarmac. So just after they lay it perfectly smooth like a billiard table, and then as time goes on you get these bumps. And I mean, I've seen video on your Instagram of this car just about getting airborne over these bumps, so it must be incredibly difficult to control the car at that sort of speed over those bumps.
Yeah, it's compare it to, imagine downhill mountain biking through a rock garden. That's like a similar experience. Yeah, it's tough. You got to pick your line, and it changes. They repaved the mountain in places this year, and it was a bit better. And then as the week went on, it got rougher again. It got bumpier, and you saw several competitors blow through a turn called Cog Cut. These are all ABS cars, and I don't know if you're familiar with the ice mode that ABS can get into, when it basically gets confused as to how fast the car is going, and everything's locked up. It will just bleed off all the or the brake pressure, and then you're just sailing off into into, as it turns out, a railway track. One of the cars managed to actually hit the rails off the cog railway. So yeah, you don't get it anywhere else in the world. I don't think anything that harsh. Well, it helps us. I mean, my car's very stiff because all the downforce. It's making we're probably making 2 tons of downforce at top speed on the mountain, 2 metric tons. So car's sprung stiff, but that downforce also helps keep the car on the ground. So yeah, you're basically pulling negative. The belts are pulling you into the car onto the ground when you go over the bump. So you're pulling negative G's, but but the downforce is just keeping the car down. So it's stiff, it's uncomfortable, but it actually does quite well and keeps the tires down. I was following Randy Post in the Tesla Plaid, and they just didn't get the rear suspension right. And even rolling down the hill, the back end of the car would buck about half a foot in the air over some of the bumps. So that's the car, that's heavy, so has momentum behind it. The aero package is nowhere near as potent compared to the car's weight, and it didn't quite get the damping right and the thing. And yeah, you got a car that's taken off.
Yeah, last thing you want. All right, so coming back to practice, we've just sort of talked about the fact that it's split into 3. So literally the only time you get to put all 3 sections of that mountain together is on the Sunday of race day. And even leading up to it, your testing is somewhat limited. And we'll talk about the fact that yours was a bit more limited than it should have been due to some issues. What are you doing there in order to build your experience and start to memorize the track? Are you focusing on simulator work to improve, or onboard video, or a combination?
So first of all, actually splitting up into 3 really helps learn the course because you do it in bite size. So that is super helpful. The biggest issue is you actually end up not ever driving some of the turns, because between the sections you need a space to slow down, turn around, and wait to come back down the mountain. The same little start line. So there are turns we never do until race day. They're around basically some fast sweepers before Glen Cove, and then basically a left-hand sweeper around Devil's Playground. So you go into that just like a rally stage on race day. For me now, being experienced, just a little bit of onboard just to refresh your brain of all the landmarks and what to expect, and just try and dig out in your memory the rhythm you had previously. Simulator's really good as well, just to create that mind map of when to expect each turn. I think there's no excuse as a rookie to turn up to the mountain not knowing where the next turn is going to roughly be, because with footage, with simulator, you can be ready to anticipate each turn as it comes along. The other thing that's really useful with a simulator is understanding where to find time. And that's both as a driver and as like how you set up a car and what you focus on in terms of performance upgrades on a car. The simulator is great to go and try stuff out, crash, and see what does and doesn't work. So I use that a lot, actually, to understand performance sensitivities and maybe where I look for time in real life, basically, see if that adds up.
In terms of software for simulation, there's a couple that I'm aware of that have Pikes Peak as a track. What are you using?
I would always recommend to people use the Dirt Rally when you're first learning the course, because they also split up the course into 3, so it's just bite-sized, manageable, so you can start to create that mind map. The track isn't accurate, the car physics and the tarmac are terrible, so it's not that much more useful from that once you kind of figure out what all the turns are. Then there is a good build with a set of course, I think it's called the Simtrax download you'd go and get, and actually they've done a really good job of using I don't know what they use, GPS data or something like that to pretty accurately model the course. And yeah, there are a couple of turns that aren't quite right, but overall that'll get you there.
Okay. All right, let's jump into this car in a bit more detail. So you've already mentioned it's a Wolf chassis, obviously modified. You've got the K20 as the stock engine, but 250 horsepower, naturally aspirated, obviously was never going to cut it. So we'll talk about how you fix that. But for a start, you've kind of dived into this maybe a little bit, but pros and cons of that as a starting point, and anything that's sort of limiting you compared to the likes of Remain in the IDR, electric power maybe notwithstanding.
Yeah, electric power notwithstanding. So Wolf's a fantastic car. It's a light tub, some really nicely engineered pieces on there. The chassis I have is actually their first car they made, so their latest stuff is even better. some of the stuff they carry over to that new car, the uprights, for instance, are just beautifully fabricated pieces that are light, stiff, and hold power levels that they weren't originally designed for. So great bits of engineering on there. And I was actually got to chat with Romain about my car last year, 2021, and I think actually the Wolf would be a better car choice than the Norma, to be honest.
Okay.
The Norma, I think, as it's still a good choice, but it when you want to go extreme with Pikes Peak and it's that lightweight, and the other thing you're dealing with is rear wheel drive as well, and that's a really interesting topic in itself. And my stance, as you can see, is rear wheel drive is faster than all wheel drive, for the simple fact that you save the weight of the drivetrain. It's about 70 kilo you would have to put into the car to make my car all-wheel drive. And where it would help is actually through the mid-speed turns where you're rolling on the throttle early, and you can use diffs and vehicle setup to also make that pretty good with rear-wheel drive, also downforce. And there's a reason why 911s are very fast up there, because they're fantastic traction with that rear mass distribution. And that's what we've also focused on this car, is like, yes, rear-wheel drive is quick, but you need to carry a lot of weight in the rear to give you the traction. And then you're also relying on the downforce heavily to go and do that. So I think our mass distribution is about 3862 at the moment. It has been a little more rearward than that sometimes as well. We've come a little forward, but you need those two combinations for the car to be quick. So you're getting the mass benefit. Mass sensitivity on my car is about 0.2 of a second per kilo.
That's significant.
Yeah.
Okay.
For the total race run, so 8.5 minute race run, 8 minutes around that point. Yeah, that's just a great rule of thumb.
So, I mean, if you're talking 70 kgs for a conversion to four-wheel drive, that's a significant deficit in terms of the weight alone that you're going to need to be making up for with improved acceleration. I'm assuming you mentioned downforce, which obviously makes sense. One area that I'd assume the downforce is less of an advantage to you is through that W section, sort of about halfway up the run. You've got, again, for those who aren't aware, a section of really tight sort of hairpin switchbacks, and it just sort of seems to go forever. And I'm guessing at that point the actual vehicle speed is so low as to render the downforce much less significant.
No, I don't think
Still
so.
good.
You've got, it's still good. So, I mean, if I pulled the wings off my car, it'd be traction limited at about 140 mile an hour. So you need the wings to put the power down fundamentally. And then you've got braking zones. Wings you can brake so much later with. And then also things like tires, you need to keep the heat in them. So you need the download in the engine to the car to make these big sticky tires work through those hairpins.
Sure.
You are right. It is less important than, say, the fast sweepers and some other areas, but it still makes a significant difference. I think you need enough power between the W's, but actually what's more important is coming off the turn very, very quickly. So traction and response off of the turn and the ability to roll speed through the turn. That's what gives you the time on the middle section, because the straights doesn't really matter if you're doing 10 mile an hour faster or slower. They're so short, you're not gaining much time to it. But 3 mile an hour roll through the apex of a turn, where you're around 25 mile an hour, it's a big chunk of time. And then the other key thing is like getting the turbo switched on and the car coming off the turn quickly. So it's the lag aspect of it and just getting the car on cam. That's a big part of it.
All right, let's talk about that engine combination. And again, to reiterate, 250 horsepower naturally aspirated in the stock Wolf. You've obviously got a turbo engine in there now. What is the engine combination? What needed to be changed, and what is the turbo you're running?
So the engine we have is a pretty built engine, ductile iron sleeved, CNC heads, slightly ratio cam, but not a crazy cam. So drag cartel 3.2. We took quite a lot of time to make sure our exhaust cam timing is correct, as well as the VTEC on the intake cam we can use. We're still using VTEC as well, so we can idle the car and not foul the plugs, which is actually important when you're at altitude. You just need a dependable platform. Pistons, rods, stock crank. We've got a dry sump system on it that came from the NA car. I think that's most of what we got in the engine. We got the nice Honda Racing magnesium cam cover. It's got to be worth 3 horsepower or something.
It looks better.
It does look so much. Actually, it stops the stock valve covers rub the bodywork, so it does help us there. Actually, the space is quite tight there. So the engine's built. Nothing crazy exotic. Everything you can kind of buy out of catalogs.
At the end of the day, the K series is such a well proven engine, even in stock form. There's not massive weaknesses, and let's be honest, you're not shooting for 1,200 horsepower out of this thing either. I mean, from what I understand, we'll talk about it. Your power aims with it are relatively modest, correct?
Exactly. Yeah. We're about, I think on the mountain, probably about 600 at the start and 500 by the end. So yeah, it's reasonably comfortable. We're pushing that engine hard. It's always above $7,000, sequential paddle shift and all that. So that's where it is tough, and that's why you don't see the numbers like drag racing with it. But we're about, I would say, at the limit. We could probably get another 50, 100 horsepower out of it, and that's probably it before it being, really a consumable item.
Yeah.
Other stuff on the car, got Inconel, headers, downpipe on the car, which is great for toughness, for all the heat and anti-lag, and also lightweight. And then we've got a pretty trick cooling setup, air-to-air intercooler from PWR as well. So all that stuff's very race car. And then the turbo, we've actually had 3 different turbos on the car over the program. And this has been the first year where we've kept the turbo from the previous year. So first year we used a Garrett G25 660, and that was actually really good for the first year. Gave us maybe like 420 horsepower. These are all flywheel horsepower, not wheel horsepower.
Sure.
At the top, and probably 350 by the end. And that was great for our first year learning the car, and it was quick even with that. Next year we went to the Borg Warner EFR turbos. They're really nice. You can get the twin scroll manifolds. They have the blow-off valve integrated into them, and also the aluminium housing. So all really nice features. We're also using the internal wastegated turbine housing, and then we use an electronic actuator on that, which seems still to be the best way, I think, to control boost. The new turbo smart stuff comes with it. Some headaches around getting that to work nicely. You've got to keep that out of heat a little more.
Sure.
And you can see Ken Block had issues with that this year. Whereas we're using an OEM Honda wastegate actuator from the Civic Type R, and is a consumable. We replace those each year because of the heat around them, but they do a great job, and we're able to map some stuff around the throttle pedal boost targets that makes it an incredibly drivable car. So we used the EFR 8474 in 19. That was actually slightly too big a turbo for us. We struggled quite a lot with lag on that. But once it was making power, that thing was an absolute rocket. I think we got 156 mile an hour on picnic ground with that car. So I think it's the highest top speed recorded on Pikes Peak.
Wow.
Yeah, it's in the straight line. It's pretty good. And then we actually debuted a new turbo with Borg Warner, which was the 8370 last year. So we had that before that came out to the public, and that's the Goldilocks of turbos for this engine package right now. We went from VPQ16 to their X85 ethanol, which was also a really smart move, and that picked us up a little bit of power at the same point. So we were about, I think, similar power numbers in the end with that slightly smaller turbo.
I'll just stop you there, Robin, and I just want to unpack a few of those things that you've just mentioned there. And first of all, just in relation to turbo sizing, Pikes Peak's just such an unusual beast in terms of the altitude and the barometric pressure which comes with that altitude. And the tricky part for that is with turbo sizing, what's going to work really well at sea level with 100 kPa atmospheric pressure. When you're pushing the turbo, it's important to understand the turbo doesn't really care about the boost pressure in the inlet manifold. What the compressor cares about is the pressure ratio, which is the outlet pressure divided by the inlet pressure. Inlet pressure is typically going to be at or very close to barometric. So what that means is that to get the same manifold pressure in your engine that you've got at sea level, you're pushing that turbo very, very hard. So if you've got a turbo that's well sized at sea level for, let's say a 600 horsepower K20, you take that to altitude at Pikes Peak, it just is not going to work. You're going to be pushing that turbo probably past its critical speed and seeing failures. So generally, it's sort of what I saw when I was there a couple of years. You've got to step up a size of turbo really to make it work on the mountain. But obviously then you've got that trade-off of lag as well. So is this sort of the journey you were going through with turbo sizing and changes?
That was the first thought, and actually it doesn't turn out quite like that. What is most critical actually is the compressor inlet size. You got to size a turbo for Pikes Peak. It's Goldilocks. It can't be too big, can't be too small, and that really is dictated by the volumetric efficiency of your engine. So there is a sweet size for each engine, and yeah, you can use anti-lag and go for slightly bigger, but I like to try and at least have the turbo well match the engine, and then you add these gizmos on top of it to get a little more performance. So down at sea level, you get a lot of motorsport where with turbos where you run restrictors, and that's a very different way to tune a car, set all things up when you have that restrictor size, and you basically end up making peak power low down and then tapering that boost as you go up in the RPM range. And what you actually end up having at Pikes Peak is the compressor inlet size being a natural restrictor. That's the sonic speed of the air going into that is what dictates your power level. Any sort of volumetrically efficient race engine, you'll never struggle with pressure ratio. You'll only ever struggle with that sonic speed. Okay. So one of the things we also discovered as well is actually air filter makes a huge difference, because that intake pressure amount, if you have any restriction going in there, you end up changing, reducing the sonic speed, so reducing the amount of flow that can go in. So a small air filter versus a big air filter can rob you 50 horsepower, or a dirty air filter versus a clean one. So things that are incredibly important that people I don't see paying much attention to that make a big difference to turbo RPM speed. So you're always up against this RPM issue, and we're seeing our turbo off the start line, we're not quite tapering boost at the higher RPM range, but then from there we start tapering boost down as the revs go up. So we up boost in the mid range to keep the manifold the same, but then we have to taper to keep the RPM speed in control.
Sorry, just to be clear on that, are you talking tapering the boost to control turbo speed at higher RPM in the engine, or are you also tapering boost to control the turbine speed as you go up the mountain relative to barometric pressure? Sorry, just to get that clear.
Yeah, it's both. So we have to, as you go up the mountain and barometric drops, you have to then taper the boost at higher RPMs more, because your choke speed or choke volume, volume going through the turbo reduces. So that's on a compressor map. The compressor map is only for one barometric pressure. And then if you were to go on Borg Warner's Matchbot, and this will show you can go and put in the altitude, and actually there is a scale factor. As the altitude goes up, barometric reduces, and so your 80 pounds a minute isn't 800 horsepower anymore. Your 80 pounds a minute is actually 60 pounds a minute or something like that. So what you got to remember is that compressor map you see is a snapshot at a certain altitude, and that the maximum flow rate, which is your power capability, reduces.
Sure. Now, with that, moving on as well, you just mentioned the electronic wastegate actuator. So just to sort of paraphrase there, more recently we've seen the likes of TurboSmart come out with an aftermarket unit. Pros and cons with that over some of the factory units, but as you said there, you're using the factory Honda OE electronic wastegate actuator. Keeping the internal wastegate, Borg Warner offer this, as do some of the other turbo manufacturers, which has been unusual with the larger motorsport-oriented turbos. Typically, we go to an external wastegate. So on that front, was the decision to stick to the internal wastegate more around packaging complexity and weight saving, or was there some other driver behind that?
Oh yeah, it was actually performance. The same thing, I guess, was when I first came to turbo sizing and to Pikes Peak, I was always told you need a bigger turbine housing when you go to the altitude because you've got to wastegate more, and it's not true. You need to downsize your turbine housing for up there because you're essentially making less exhaust energy. And so you basically got to get everything you can out of the exhaust gases into the turbine, and that's where something like a twin scroll really, really helps. And that's where the EFR turbos have the smallest housing size with the twin scroll in, and the twin scroll really makes a difference in how the boost comes on. It's like a single scroll, it'll come on like a switch, whereas a twin scroll will come in steadily. So it's very, very drivable. At the time when we started that program, the turbo saw that stuff wasn't available. It had just started coming out, and things like keeping the header simple as well, and the wastegate flow, I think, is actually quite. When you're not having to flow a lot of gas through the wastegate, the internal wastegates still do well. If you've got a turbo sea level and all your sizing and you need to wastegate a lot, externals all day long. But on the mountain, where most of the time your wastegate is shut and you're building boost and I always say this to teams, and they're like, "Oh, we're not making enough power. We need to turn up the boost and all this." I'm like, "Go and see the percentage of time where you're at full throttle and meeting boost target, and it's probably less than 10%. So drivability is just key, and getting everything you can out of the exhaust gases is key, and that's actually where the internal stuff does really well.
I think that's something that's very easy to overlook with turbocharged engines in general, is the way they do come on boost, and particularly if you've got a reasonably small turbocharger that's meeting your power aims, kind of as you alluded to there, it can come on boost so aggressively that it can make it easy to overcome traction as you ramp up. Now, obviously, we talked about the twin scroll and the internal wastegate helping you with that and rolling onto the boost a little bit more smoothly. In terms of the electronic wastegate, obviously that opens up your strategy a little bit more than perhaps what is easily able to be done with a pneumatic actuator. One of the problems I see with turbocharged cars is they are so good at making boost pressure. If you put them on a dyno and you run them, past the boost threshold, maybe 6,500, 7,000 RPM for your application, and you go to wide open throttle, and it makes, let's say, 600 horsepower, and maybe it's 30 pound of boost, just to chuck some numbers out there, doesn't matter. But then if you roll out of the throttle to 80% throttle, chances are it's probably still making 30 pound of boost. Maybe the power's dropped from 600 to 590, maybe 595, but almost no real difference. So then you roll out of the throttle, and typically if you're not instigating some control strategies around the boost pressure, it's probably not till you get down to about 60 or maybe even 50% throttle that you're actually starting to see a significant drop away in power and torque. And the problem with that is, as I see it at least, it makes the modulation of the torque and the power for the driver, it's very non-linear. Like, question here is, am I on the right track with this? Is this a problem from your perspective as a race driver? And then are you using this electronic control strategy to help make the torque versus driver's foot pedal position a little bit more linear?
Yes, 100%. And I think the thing people don't realize is we don't actually use traction control on the car. And we do that because it's a simple strategy, and you can do it with and without the electronic wastegate actuators. I prefer those, but you can do it with pulse width modulation with pneumatic control. But we essentially crack open the throttle plate it's just how Motek controls throttle plates. It's kind of like an S-shaped curve, but we're like 80% open by about 40-50% throttle pedal. And at the same point, we basically do boost target per throttle pedal position. So it's a very, very linear pedal. Race day was rainy and foggy, and my boost was still turned up to 100% because I could just modulate on the throttle pedal. So you're basically, most of the torque demand is actually dictated by wastegate closing. In the end, that's what we end up having. Yeah.
All right, you just mentioned Motek, so let's talk a little bit about the electronics package in the car. Motek Ecu, what else have you got in there?
Yes, it's Motek M150. We then have I think it's the PDM 32 Motek again, and then a Motek C127 dash. That's what we have there. What else we got? An M-cell electronic cutout switch, master relay, and we've got some race grade stuff in there. TC8 for the thermocouples, and also GPS and a race grade IMU as well. So all the good stuff. Yeah, it's got a lot of trick stuff in there. We built a new wiring harness for the car this year, and we thought it was going to be simple to start with, and turned out it was a beast because we've got so many devices on there. So yeah, all around kind of Motek and race grade, and that's just been fantastic for us.
Was that new harness construction sort of driven by the changes to sensors or electronics, or was it just time to freshen everything?
It was a bit of both. The car's a bit of a mutt and a hybrid for a while, as we did a patch harness for the original car's harness to put the M150 in, and also all the turbo systems. So we had it was kind of a patch harness that plugged into the old harness, but then also had some other branches to go and plug into all the turbo stuff. And then as we got more sciencey and adding more stuff on it, just became a bit of a beast. And then the old harness was also starting to wear, and I started to see some issues with some failure with the harness. I think you experienced firsthand the amount of engines we've had in and out of the car, and that does put wear and tear on the harness.
Definitely.
So it was time. And we had a PDM and the Motek PDM go in the car as well. So we could make everything go over to Motek. We got the Motek dash as well from being kind of in the passenger seat as a secondary dash and using the steering wheel dash to an open top wheel dash right in front of me as well. So we just took the opportunity to make everything just so, I think. And that needed the whole new harness. We repositioned a few components as well, things like shift pump, battery, and all that good stuff to the passenger seat, just to help with mass distribution and serviceability. So it was time. It was a lot of work. It was one of those things where it doesn't actually net you performance, let's say, but it just makes it so much easier to work on the car and engineer the car.
Plus, reliability is obviously key, particularly when you only get one crack at it. You mentioned no traction control, but you've sort of talked broadly about anti-lag. So I'm interested in that strategy. Obviously, anti-lag, it's a given with rally cars. I can see some potential advantage in terms of aiding boost response, particularly in some of those lower speed corners like the W's we've talked about. My take as a tuner on anti-lag, so I always had customers with road cars coming and asking for an anti-lag setup, and I try wherever possible to stay away from it because people don't understand how it beats up on engine components, particularly the heat it generates in the exhaust manifold, the heat that the exhaust valves and the turbine wheel are exposed to, and that needs to be managed. So that's why I very seldom would do that for a road application because it just causes more trouble than it's worth. So talk us through the sort of mindset and the anti-lag setup for yours and how you're using it.
The mindset was mainly what you have, but for race cars as well. And that's why it came down to the Goldilocks idea of turbo sizing. First, we get your turbo sizing right, but you come to a point where you're trying to extract every ounce of performance of the car, and you do need it a bit. So we've always had EGTs running on the car, and that's really helpful for diagnosing any issues as well as controlling the anti-lag to make sure that the exhaust temps are staying below turbine limits and all this good stuff. So that's the first thing. Also, not asking for too much from the anti-lag. We're probably commanding about 8 pounds a boost, and that's 6 to 8 there. And then it's on a driver controlled switch. So having run with and without anti-lag this week, my qualifying time, which was a record time, was without anti-lag. At the bottom of the mountain, you don't really need it. And when you have this really good throttle response and the ability to drive the turbo, you can, similar to Ayrton Senna back in the day, who would do square stabs to get the turbo to spool up. I can just slowly roll into the throttle to get the turbo going, and I can anticipate that very well. So you don't always need the anti-lag. It's only when you go up in altitude where you need to keep a bit of energy in the system where that really matters. So we'd be turning on the anti-lag around Glen Cove, and then we'll be running that up through the W's, and maybe by the top section, we maybe go one setting more aggressive. Fuel usage is another thing to consider. You use more fuel doing it, and so that's weight you've got to take up, part way up the hill as well, which slows you down. So it's all those things and compromises to consider.
Yeah, definitely. I think those things as well, on face value, are very easy to overlook. Just briefly, I'm interested to dive into cooling. And I mean, my own experience running Ford Focus with a GTR R35 engine in it up Pikes Peak, and that was never built for Pikes Peak or competition at altitude. And I mean, I think everyone kind of understands with a broad knowledge of how engines work that when you go to Pikes Peak, the engine is going to make less power because the air is less dense. And that's sort of a given. And I mean, it's obvious in hindsight, but what I had maybe not looked at or considered is that your cooling system doesn't perform as well either, for the very same reason. You don't have such dense air passing through the likes of your intercooler and your radiator. Interested to hear, is the base Wolf cooling package in terms of the radiator, obviously it never had an intercooler, is that sufficient, or did that also need upgrading for Pikes Peak use?
That did need upgrading. Now, I say to people, newcomers to the mountain, if you keep your car naturally aspirated, actually the cooling package is the right size because you lose the amount of power out of the car. So actually your heat injection into the cooling system reduces at the same amount as your radiators lose efficiency as well. So an NA car typically is okay, but then the turbo cars, you then wind in boost to make that power back, and that's where the headache comes. For us, we ran the stock radiators for a couple of years, and they worked pretty well. That car was way overcooled. It doesn't have any fans on it. If you were to idle an engine with the car slightly pointed into the wind, it would never warm up because it didn't have a thermostat. So it was really good from factory. And another reason why I picked the car was that it was their first go at it, and their radiator intake in their side pods were just a little too big for 250 horsepower, which is brilliant when you're making 650 because you can cool the car properly. To the first iteration of the car, we ran the intercooler hanging off the back of the car, and that really helped with us for traction, and actually aerodynamically works really well. But the mass was a bit too far back, and there was some stability issues with that. So in 2021, we went to a whole new cooling package essentially for the car. So the left-hand pod is just for the water circuit, and then the right-hand side is air-to-air intercooler and an oil cooler. We were able to move all that, these big heat exchangers into the side pods because we work with PWR, and they just have really efficient cores. You go and look at the detail of how the core is. It's able to just transfer so much heat with that. So water temps, actually, we don't struggle with at all. We now run an electric water pump, and that's not running 100% even with anti-lag and all that good stuff. So that has some headroom. The intercooler oil stack is a little more marginal for us, and we were running a water spray system on it as well to try and help out with that. But that was in the right-hand side pod. So yeah, trick stuff, motorsport grade pieces in there, and it's still a little marginal. But you'll find, as you wind in the boost, you make more heat, and that's just tough to cool. And you see some of these cars with monstrous coolers all over the car. But that's a huge performance deficit with all that cooling in there. Like all these things, you need just enough cooling. If you have too many coolers, it's going to be slow. It's too much weight. It's aerodynamic drag. Typically, coming with drag is you reduce downforce as well. So you need to be on the marginal end of stuff with these coolers.
It's all about finding that perfect balance and getting it just right.
Exactly. Yeah.
What's probably easy to overlook with the Pikes Peak event is it is ultimately a team event, and obviously once you leave the start line, it's all about the driver. But it's, again, I've kind of already talked about it briefly, but you lose sight of everything that is required to build up to the event, put the car together, and then run the car during the event with all those early starts that we've already discussed. And you're competing and beating everyone with the exception at this stage of the likes of Romain Dumas, which has the backing of Volkswagen. I'm guessing essentially an open checkbook approach to building that car and running it. I'm guessing you don't have an open checkbook. So let's talk about the Sendy Club and what is that team, who's involved, and what are their kind of roles?
Yeah, this is one of my favorite topics. I'm very lucky that I have a lot of smart, talented friends who love cars and motorsport. And the Sendy Club came about as a cancelled Pikes Peak program with Faraday, and we were due to go back in 2018 with an electric single seater that we had designed, and they pulled the plug on, unfortunately. But there was still a want and a desire to go and race. We did try and do it electric to start with, and that was too hard, too expensive in the time given. So we went to the internal combustion route. Now, the people we have are some of the brightest minds in the automotive industry, and it comes from things like powertrain controls, prototype builds, mechanical engineers, and performance analysis people. So you go and look at, if I was to actually pay these guys, I couldn't afford them. Like, this program couldn't pay for that. And I don't think, it'd be comparable, if not more, than Volkswagen and what they had. But it is volunteer work, so I don't have them 100% of the time. It's when they can make time for it. So that's the big difference. Luckily, we're all really passionate about this project and very driven with it, and I've been lucky that it's become more and more full time as we have started to bring money to the program, so that I can focus more of the time on that, as well as others as well. I mean, you look at Zach Perkins has been featured in some of your videos. He's an absolute artist in terms of wiring and welding as well. He is, for a guy who doesn't weld, does some of the most beautiful welds without any practice. You can pop on a TIG welder and weld 321 stainless with no practice, and it's beautiful. So yeah, just very, very lucky and privileged I have these people around me, and it is the reason why this program is so successful.
What I do often see is that sometimes having unlimited resources and unlimited budget can can actually hinder. And I know that might sound like a pretty unusual statement, but I've always found teams that I've worked with where the budgets have maybe been a little bit more limited or refined, it makes you think a lot harder about the solutions available and making the best choice for a particular solution or problem that you've got. Do you think there are advantages over the likes of Volkswagen Motorsport that the Sendy Club, you guys actually bring to the table for Pikes Peak?
I think compared to Volkswagen in particular, not so much. That they were just given very different constraints of what that car needed to be, and they also had a very short time frame. I always think of this as, like whatever you do, you're resource limited, and resource is time, talent, and money. They're the big three. So if you have an abundance of that, you'll typically maybe focus on the wrong things, and maybe it's not only that you will spend money in the wrong place, you maybe try and bite off more than you can chew. And I think this is, most Pikes Peak teams are guilty of this. You could even say we were this year in picking too many projects at once to go and do on the car. I think what's key to start with is, knowing we've always been frugal, and so every dollar spent has to be right. You don't want to go and waste anything, and that just means we do checks and balances in the engineering before we go and spend the money, and I think that's key. And because we are engineers, we have the tools to go and know, is this going to make the car faster or not? And it is always tough. And there are a few leaps of faith you have to do, and sometimes it doesn't work out with these choices. And if you have a bit of a leap of faith, a bit of a risk in one of the choice, plus it being very expensive, we probably wouldn't do it. And we sort of had the option of doing some cylinder pressure measurement this year that somebody wanted to partner us with that. In the end, I ended up not wanting to do because of the time effort going into it would be so great. It would come with some risk of reliability. And you go and look at the performance that would come out at the end of it, wouldn't have been that much. You're talking 20, 30 horsepower. And where we're still sort of refining maps in some areas, that is, a much lower hanging fruit of performance. So, I think with a load of cash, we could spend very wisely as a project. And it's maybe the teams who do get a lot of money, maybe don't spend that money on the talent and instead spend it on parts they don't necessarily need. So I think, and you see this actually at Tesla, and it's a good comparison between Tesla and Faraday at the time when those things were going. Tesla was always cash strapped, and so everyone had to be as innovative as possible and get every last ounce out of what they had. And I feel like we're the same, whereas Faraday had a nice pot of money to get going to start with, so a lot was spent maybe on stuff that wasn't so important for their initial success. So that is a huge factor of it. And I think, if you leave people a little hungry, they're always a little more hungry, to go and do things as best as possible. So, yeah, I think it can ruin a project. But Volkswagen's effort, I don't think the budget held them back. I think it was timing for them of what they could do was really the limit, and also having to meet some corporate desires in terms of it, A, being electric, B, looking a certain way. And
yeah, I guess there's always a backstory of a set of compromises that are put in place, particularly with those large corporates. I mean, I think the takeaway for me in terms of just purely the budget side of things is that sometimes a budget that's too big can make you lazy and complacent. I think that's probably like how I'd summarize that. Let's move on to what you changed. So if we can maybe briefly go over, you obviously had a very successful package that was, for all intents and purposes, doing a great job. What did you decide to change for the 2022 running?
There was a huge amount of change on the car from 19 to 21, and that was that cooling package and some proper CFD on the car. And with that kind of that big jump forward, you always have some things that didn't quite work out as exactly how you'd wanted. And the big one was the aero balance of the car. We could get the front end working if it was very low and within a very small range. That's no good for Pikes Peak. So we wanted to basically make the car less aero sensitive to acceleration and ride height. We know from the performance sensitivities as well of terms of pace on the car, aero downforce is one of the places you go for the biggest gains. You sometimes see all the cars there with big wings on, but as a full system, it doesn't always work so well. And the other thing with aero downforce is you've got to drive it. The car doesn't become faster with it. You have to use that downforce. You put more power on a car, most people go to full throttle, so you're realize the performance gain there. But things like better brakes and more downforce, you've then also got to follow through with driving the car faster.
So you're talking there about trusting in the aero and trusting that you're going to be able to go around that corner or brake later compared to what you had with less or no downforce.
Exactly. And then the other big thing, and it's the most sensitive factor for runtime, is tire grip. The more grip you have, the faster you go. That's the thing you want. Downforce is essentially just giving you more tire grip, just in a speed sensitive way. And that's where we were able to bring on a new partner with Yokohama, that we got some very exotic tires to go and pop on the car, which is their Super Formula tire. So that Super Formula is a series out in Japan. It's their premier open wheel series. Used to be called Formula Nippon. A lot of F1 drivers came from that series, and it's still producing some great people. And those cars, I think, up until the rule change in F1 in 2017, when they went back to bigger downforce, those Super Formula cars were faster in the turns than F1. So These cars are there or thereabouts, yeah. And for us, it just so happened that the tire size they were is a bigger tire size, and we could just about squeeze it in the car. Everything's like barely fits. We had to cut away a lot of body work. We had to modify some suspension arms. We had to, the front tire diameter is quite a bit different. So we had to make some spaces to get the steering offset, okay. So it's not perfect. If you do a clean sheet, you wouldn't set the suspension like that, but it works. And the tire itself just responds so much better to the extra downforce. And that just gave us a huge step up in performance there, which was great. And then for the front-end aerodynamic sensitivity, we ended up actually cutting away the floor that was making the majority of the downforce previously. So the best way to make a floor less aerodynamically sensitive is just to remove it. But then we needed to bring that back. So then we put a much bigger front wing on the front. Front wings are quite nice because they do work in ground effect, but not as sensitive as the floor itself. And it's not troubled by anything else, in front of it in terms of weight-wise. So you can do the analysis pretty accurately on it. And so we just went for something that was a lot wider, bigger main plane chord and slightly deeper, and then more flaps as well. And that brought the balance back. We did also have a tunneled floor that was supposed to go on the car, and that was going to give a big jump in downforce, I think by itself, like 30-40% without any increase in drag. And that, unfortunately, we'll talk about this, the fire we had at the start of the month stopped us fitting that floor to the car. So there was, the aero package wasn't complete this year, but we kind of got half of the way there in the car performance with half of the aero package to the IDR. So that was actually really, really good to see.
So a couple of things, and just to be clear, I'm definitely not an aerodynamicist. I've just got a broad scratching the surface understanding. It's something I do want to learn more about. When you've said you've cut away that front section of the floor, which was currently producing a lot of the downforce, in order to reinstate that downforce using the wing, I understand that reduces the ride height sensitivity of that downforce, which is great. Generally, as I understand it, again, I may be wrong here, the downforce that you can produce with an underbody, the underfloor, etc., generally comes with less drag than getting that same level of downforce from a front wing. So is there sort of a trade-off there? First of all, is that correct, or am I off the track? And if so, is that a trade-off?
Yes, 100%. That is a trade-off. But what you have at Pikes Peak is the physics of a race car works slightly differently because the air is so thin. So drag isn't such a big deal. Let's say up there, there's this thing called the Isochronal Ratio that you see in Formula One and things like that dictates what downforce level you put on your car for certain tracks, like a high speed track like Silverstone. You need to not have any drag. So to put a downforce on, you need to be making like 5 times the downforce compared to drag for the car to stay the same speed. So the Isochronal Ratio is basically saying it's like the ratio of downforce to drag for the car to stay the same performance, basically. So it's anything that you make downforce with less drag than that, you'll put on the car because you'll go faster. If you're putting that downforce on and it's draggy, that car will go slower. Does that make sense?
Yes, I understand. Yep.
Yes. So somewhere like Silverstone or Baku, you're talking 5 or 6. So you need 5 times the amount of downforce as drag for the car to go faster. Somewhere like Monaco, you might be down at like 2.
Sure.
For Pikes Peak in our car, it's half. So long as you're putting half the amount of downforce as drag on, the car will stay the same speed. So it's really not drag sensitive at all. And actually putting drag on is helpful for brake temperatures because you reduce your terminal velocity and the car will slow quicker. And then also for like a dragster with a parachute, if anything goes wrong, you can pull a chute and it'll slow you down. That drag kind of does the same on the mountain, especially on the rear wing. It will straighten the car up and you can get out of it and get back
you
in
out of
control.
trouble.
So yeah, that's really useful.
So you mentioned there you've developed that in CFD, and assuming that it's not a case of garbage in, garbage out, you're going to have a pretty solid idea of how that should perform. So obviously that's a great starting point. In terms of validating that in the real world, though, particularly with the altitude aspect of Pikes Peak, I mean, there's really nowhere to test other than Pikes Peak. Did you do any real world running with the car to validate things prior to getting to Pikes Peak? From memory, it looks like you finished building the car at Pikes Peak, so I'm not too sure how that worked out.
Yeah, we did a little bit of track test away from the mountain, and most of that, to be honest, is just to make sure the wings don't fall off. That's like a bit of a harder one.
Step one in aerodynamics, make sure everything stays attached.
Exactly, and you do get some weird effects with the, I think they call it aero acoustics, things like fluttering and stuff like that. That it's very hard to even simulate, let alone, we do the 80-20 approach with CFD. It's not going to be the most accurate correlated, but we get trends of what's good and what's bad, and then we put it on the car. And this is one of the areas I'm very good at. It's just feel. I can tell you where the Aero Balance is, what's going on with the car, and with a bit of data in terms of shock pots and things like that. Okay, we're not getting absolute forces and drag numbers out, but we're getting an idea of where things are. And actually, we get from stopwatch at the end of the day is like, okay, we're expecting to be 10 seconds faster on this section, and we were 8 seconds faster. So, and I can think of, well, I was not as fast in this turn or that turn. So it's about where we were. And that seems to be the case. Everything we've popped on the car roughly works as expected.
That's always satisfying.
Yeah, it's really nice. And to go from that level of correlation, which is very light, and I appreciate some could say it's slightly anecdotal in some places. We don't have full understanding of what's going on, but we also keep our aerodynamic devices very simple. The front wing is 2D profiles. There's only the end plates that have some 3D into it. Same as the rear wing and the floor as well. It's not crazy complicated stuff that's relying on vortices and things like that to switch on and off. These are just basic rudimentary shapes. And with that, then you can, basic rudimentary balance, and what we get out at the end of it should be reasonable. And that's what we found.
All right, well, let's move on. I think we've got a pretty good understanding of the car as it sits and the changes made. So let's actually move on to Pikes Peak 2022. And it's probably fair to say anything but plain sailing, correct?
Yeah, it was a month. It was hard work.
Talk us through the highlights reel, or the lowlights reel, as they may be.
The lowlights reel. So we had a lot of stuff going, a lot of new stuff onto the car, which is to step forward, set us up for the future. Actually, 2021 we had a lot of new stuff on the car, and we just got lucky. I think that everything worked out about right. But for this year, a lot of new stuff came on. There was a new wiring harness on the car. Still has some troubleshooting in terms of things like CAN networks for all the different devices, getting all that configured right. And there's always going to be a couple of mistakes you have to go and fix there. We had sort of an issue with some pin outputs we used to control the VTEC weren't right, so the cam control wasn't right for a while. All that stuff just holds you back. Shakedown ended up extending a couple of days, and then and also shakedown was delayed by a month or so. So we were running a month later than we wanted, and we had some issues there. And then on top of that, unfortunately, we had a failure, and a oil line install issue that basically put as a line that was, just because the packaging is tight, the line had to be quite straight, and it was installed so it had a little bit too much tension on it, and after a while that failed. That popped open and then unfortunately caused a fire. It was a minor fire at the time, but then my fire extinguisher didn't work as it should. It was an in-date bottle, everything was testing okay, but the extinguisher didn't go off, so we ended up having the car burn for about a minute and going through quite a few bits and pieces. Yeah.
There's video of that as well, and
yeah.
I'm going to talk a little bit about a link to a YouTube video, which I think anyone who wants more information should definitely go and watch. But on Pikes Peak, it's a very long hill climb, and obviously they can't have marshals stationed every 50 meters along the entire length of the hill climb. So were you fortunate enough, and where you stopped there, that you were close enough to a fire marshal that obviously I've seen in the video they ended up coming in and extinguishing the fire?
Yeah, really lucky. Really lucky we were around somebody with a radio as well to call them up. I probably break down more often than most on the mountain, and that's as we're always developing stuff on the car, and with that comes some things that work and do and don't work. And so I have my fair share of stoppages, and for some reason I always end up stopping at the same place where this chap called Joel, who's a photographer, is, and he's well integrated with the safety crew and has a radio, so he was able to call and help immediately, and then they turned up, shortly thereafter. I mean, you've seen previously things like, I think, Ken Block that burnt down a Ford Escort in a rally stage where, safety is much further spread out than what Pikes Peak is. Pikes Peak safety is really good in that aspect, that there's help isn't too far away each time.
What was the sort of damage analysis on that? Because usually a fire that burns for a minute is going to be borderline pretty catastrophic with a huge amount of damage.
Yeah, we were lucky in that the oil that caught fire was near the top of the car. So the fire itself was on top of the exhaust manifold, basically. So we burned through some wires, the coils, a few coolant lines and things like that, and then the bodywork as well. Bodywork took a real big toasting to it. So something like that, when you have a fire like that, you have to strip the car all the way back. You have to clean it. It makes a huge mess. We had to go and find the issue where what burst, what broke, and confirm that as well, which takes time. And because that's the start of race month, the whole team wasn't out. It was me and just one other guy actually working on the car and sorting it out. So that took days. With a team of 12, that could have been fixed and sorted out in a day. But for the two of us, that took 5.
So that obviously cuts short your testing as well, which then impacts on your experience and knowledge with the car and the mountain. Exactly,
just a back foot each time, and then you've got to go and almost do bring up again and shake down to check everything all you've changed is okay. So you're back to square one with that. It is a huge setback.
All right, so we get past that. The car's basically back good as new, and from the outset, if you don't look too close, essentially you'd never know. So how did testing go from there? Plain sailing now?
Yeah, no, it wasn't. Again, we had the day after that, we had a good day on the lower section, and we could really start to learn the Yokohamas on the mountain, which was, something that was nuanced and took a lot of understanding there. So we had a couple good days on the mountain to understand that. But then we also had some issues around sensors. The engine's rigidly mounted to the car and is semi-structural. There's a lot of vibration going through the car, a lot of load going through the car. So stuff that isn't wear items becomes wear items, and we're slowly discovering that, and we really need to start lifing more components and sensors and things like that. So something as a small team that you don't really have that luxury of time to spend on that, especially when that doesn't gain you performance, just gains you reliability on an event you can get a little lucky with, let's say. So we had an oil pressure sensor that was just starting to read a little low now and then, and would throw up warnings and issues. And when you're running on little sleep and because we're such a competitive program now, and if everything goes right, we're race winning, you don't want to risk blowing up an engine or having an issue. So we always err on the side of caution, and that's what we did. We lost a day to that oil pressure sensor. We had then a cam position sensor go. Again, it was the wiring that was fire adjacent, so maybe questionable whether the fire actually affected that, and that stopped us another day. And it was a really weird failure. We had it on the Sunday previous to start with, and the car just conked out. Didn't work. All the dasher stuff was on, but couldn't run the car. Tried cycling it, turning it on and off. Wouldn't fire up, so rolled out to somewhere safe. 10 minutes later, just tried again. The car fired up, drove back down, and then ran the rest of the day fine. And we were like,
always reassuring.
Yeah. So we knew we had that gremlin in there. It was really hard we couldn't find it in the data, basically. Following week, exactly same place, situation, same thing happened. And we were luckily then we were on the mountain, we had more people around us, we were able to go and diagnose and find that issue of that sensor. We were 90% sure of it, and then we changed it, and it was good.
The other thing I'll mention there as well that sort of goes hand in hand with this is that due to that nature of the early starts, you've got a team that's running on very little sleep, and then when you add in having to essentially rebuild half of the car due to the fire, it's amazing how a lack of sleep, particularly as it builds up over a week or so, starts to affect your cognitive ability, and what sometimes is a simple thing to spot and solve just isn't that obvious.
Yeah, this is a huge problem when well-established teams who racing in, typical road racing stuff come to Pikes Peak. Their experience are a good team, they've won, and it shouldn't be too hard. And they come to the mountain, they just have their arse kicked. And it is an endurance event, but it's not like a car running around for 24 hours. It's like a physical one and a mental one for each and every person on the team. The altitude just compounds that because it just exhausts you. And the other thing I find same for me as anyone, when you're working on cars, you get tired, you start slowing down, you become less efficient. You'll take 2 or 3 times the amount of time to go and do a job than if you were fresh and ready to go and do it. So just looking after people and like telling them to go to bed and stop, I think is a big part of teamwork there, and giving yourself enough time to go and work on the car, and also being realistic in the amount of work you can get done in a day. It's just really, really important there. You've got to pick your battles and you've got to rest as much as you can. You're still not sleeping that much, but that little bit of sleep is just so important.
Definitely. All right, well, fast forwarding through to qualifying, and again, qualifying is a little unusual with Pikes Peak. It's run on that lower section of the mountain, so you've got the 3 groups practicing on the 3 sections of the mountain, so basically the 3 groups qualify on different days, and you did manage to get it all together and iron out all the bugs on the qualifying day in the end, didn't you? How did that all go, and you're happy with everything?
The qualifying was eventful. We had, this is like one area on the car, we keep blowing a boost tube, and it was something that we know how to fix, but we just weren't able to go and do it properly, fix properly. We were able to countermeasure with some different clamps, but we ended up blowing a boost tube off there on the first run. First run is just so important for qualifying, especially for us. If we're fast, we're way faster than everyone else. So we need that banker run in, and then we can go and push and really go for time. And so we ended up running up the mountain with no boost at all. And I think that probably works out to be like 150 horsepower. Top speed of the car, I believe, was 72 mile an hour there. And it was a bit like driving a rental cart up the mountain. But the time we set was good enough for midfield. It was like a 4:20. And that just shows you, again, people come to Pikes Peak power obsessed. And with a car with a VMAX of 70, we would have qualified, I think, like 3rd or 4th and unlimited with that. So
it's definitely not everything.
Not everything, but from there, that just put us on the back foot. I was trying to make up for it in the next run and push too hard on the bottom. And again, I was still learning the car. Like, I'd had 2 competitive days in the car on the mountain previously, and some of the features of our spring package makes it, you have to be a bit patient from weight transferring on the nose and heavy braking to then throttle and turning. And I was just asking for a little too much and spun the car. We were actually up to that point. I got the onboard up to that spin. We were on pace with the IDR on that bottom bit of the mountain. That's where we're very strong, and the IDR doesn't pull out its advantage till that next section, but just showing you where we were there at that time. Spun the car 180, had to kind of Austin Powers reverse it around to point in the right direction and get going again. And actually that time we set on that run, even with that spin, was still pole position at the time in class, and still would be. And I think was good enough for 3rd overall. So again, the pace in us in the car is pretty good. So we can get away with some of these mistakes. That was one of my mistakes. I try and avoid doing that. And that was I should have done it on the last run. I should have done my last run second and then that run last, because us getting a 3rd run was not a guarantee. You basically you're waiting until 8:30 and no more people can go up after 8:30, and we were leaving the line at 8:28 as it went through the running. So
cutting it fine.
Skin of our teeth, yeah. And I just brought it back a bit. I didn't run anti-lag on the car. We ended up running some groove tires because we had to turn the car around really, really quickly, and we had to get in line to make sure we got that start time, so the tire warmers weren't on. So we were running with slightly cooler tires, so we could run some, we call them the groovy boys, that just created a bit more heat in the rubber itself to work at those lower starting temperatures, which worked out. And I put down a good time. I think it ended up being like a 3:24, and was about 2 seconds faster than Sebastian Loeb ever did in qualifying. So
on a compromise run, you're still 2 seconds faster than Loeb, fastest ever qualifying time for an internal combustion engine. So with potentially, or obviously, more up your sleeve, that's not a bad place to start. And I'll just sort of clarify as well, because people might be thinking, well, what is the relevance of a qualifying time at Pikes Peak when you're not racing off a grid with other cars? And I mean, obviously, first of all, there's the bragging rights of being fastest. It's a pretty good place to set your mind, get your mindset right for race day. But more importantly, and I mean, I've only been there 2 times, but both years I went, we had exactly the same experience. 2022 we'll get to, it was a little bit different, but generally that mountain's weather patterns are very bizarre. And the 2 years I went, we sort of started the day with the dry track, and everything was good. The weather was clear, and then sort of by mid-morning or midday, a weather system had come through. And I think the second year I went, they actually could only run the last half of the field to Glen Cove, I think, from memory, or something like that. It was just snow and sleet at the top. So you want to get your run in as soon as possible, and that qualifying time sets your starting position. So Moving on to race day, I just sort of alluded to the weather. Obviously, it's not a year that kind of went down in the history books for the right reasons. Conditions less than ideal. Talk us through it.
Yeah, so we had basically a cold front come through just over the extremities of race day and the day before and after. It was forecast for like 6 inches of snow at the top, and it looked really bad. It looked something similar that was going to happen the year before, where it was just ice at the top prevented that. But luckily, A, they had the road crews working round the clock, and B, there just wasn't so much snow up there, so they were able to keep the road clear. But the big problem was the fog stayed, and there was just fog all the way up the mountain. And with that, the mountain typically, if it's clear, precipitation, moisture on the road will just evaporate very, very quickly. Even if it's cold, even if it's freezing, you'll see steam coming off the road surface, and it goes very quick because of the ambient pressure. But with the fog in, it just made everything wet and kept it wet. So we were running the way they do the run order. You don't want to be first on the road as fastest runners. They put a couple of the slower classes in, typically people who are not in contention for the overall, first to kind of clean the road, get everything sorted out. And then I ran, and it was still wet 80% of the surface. And then one, the small section which was not in the cloud was dry, but still patchy wet, so you couldn't push flat out. And then by the W, so the midsection and the top, the heavy fog was there, and it was really hard to deal with. And you're talking, open top car. I think that makes it a little harder because everything's going onto your visor, and then it's just dense patches of fog that was, I could barely see my dash. I couldn't see which gear I was in. I think the cog car ended up doing it second, because I thought it was in third, but I couldn't see the number on the dash.
Again, obviously we don't have the benefit of visuals here, but for those who want to check out just how bad it was, a really great video that I just watched yesterday that you posted on your Instagram from Superfast Matt on his YouTube channel, which kind of documents your experience at the mountain as well, but that onboard from race day, I mean, it's some next level. So we'll put a link to that video for people who want to actually see what it was all about. I mean, I have to ask, with the conditions there, does it become more a case of who has the largest balls to drive through that fog and hope that they remember what the combination of corners coming up is?
Maybe. I think it's a couple things. Like the fog will flow in and out, and then also depending on the car setup, what you have, how clean your screen is, you can maybe see more or less. That makes a difference. Familiarity with the mountain, being able to read the road from landmarks, and then the confidence in the car that you can do an emergency maneuver, something like that. You saw David Donner second overall in a pretty much stock 911S. He had the benefit of tires, really good groove tires and that work at low conditions. Race wets are not designed to work at 0 degrees C. So he had the rubber there, and the car's soft and compliant and has all the safety systems, and it has ABS, stability control, all that. So if he was somewhere unexpected, he could just jump on the brakes, pitch the thing in, and he was more likely to do all right with it. When you got a stiff aero race car that's doing 30 mile an hour and in freezing conditions and some ice around it doesn't do well when you have to do some emergency avoidance or something like that. So it is a little bit also around the car. And then, there is also an element of how much you want to risk it on the top, of how confident you are. I kind of knew I was really fast on the other sections, so I didn't need to put in the level of risk on the top to do it. But I was pushing as hard as I could. I think if I'd have risked more, there might have been like 2 or 3 more seconds, and then there was probably 50-50 if I made it to the top. So we're not talking much difference there.
Obviously, the risk reward calculation you did worked out, because you did win by a reasonable margin as well, from what I remember seeing. Is it sort of a case of what could have been, though? Because obviously winning the event is ticking that off the list. It's one of the things you wanted, but I'm assuming really what you were aiming for was a faster time and maybe an outright title.
Yeah, I think in the end, for me, it wasn't the end of the world, because we had the setbacks at the start of the month and we weren't bringing everything we had this year. It wasn't that feeling of like, we could have almost done it on the 100th. That would have been amazing. I think in the end, we would have been there or thereabouts, breaking the internal combustion record. But that's still not the outright mountain record. So I come to terms with it before it happened, and also very excited to race the mountain in adverse conditions. I also think that's kind of cool, and is a talking point for the 100th. Ripping up that mountain when it's tricky, I think as a driver is, it's kind of nice to say you've done that, and you can. Most of the other race cars were a lot slower in the wet, let's say, than the road cars, but our stuff was still very, very competitive. So that's nice to have that aspect of it. You can't get into the what could have been mindset at Pikes Peak. The mountain decides when you're going to run. 5 years I've run the race, and I still haven't made it to the top without weather or a car issue. So I've never set a representative full length time. 3 times king of the mountain, and my finishing times don't mean anything to me still.
There's always been something left on the table.
There's always something there, and that's just the nature of the race. And also why it's so impressive for Romain and Loeb to just turn up one year and set those times. So hats off to those guys to do it in one. It's taken us a little bit to get to that point. And I think that's, again, it just shows you the difference between a smaller program and the big program, that you can spend the money and have a higher percentage chance of success with that. Obviously money doesn't buy you weather, but everything else at least can put you in a much more certain position to succeed. Absolutely.
All right. Well, I think we'll move towards wrapping this up. And the first of we've got 3 more questions we ask every guest, and the first of those sort of really leads into maybe what's going to happen for next year. So that question is what's next and in the future for you? I'm assuming unfinished business back next year with some further changes. What have you got planned?
Yeah, I think so. It's always this sort of delicate balance of, do we just continue with the small leaps, or do we go for the big leaps in improving the program? But we'll be back at Pikes Peak, and I will be there with something that will challenge for the hill record. The McMurtry fan car did something very impressive at Goodwood. The fan car is actually a concept I've been looking at for a while now as well. So with that, the possibility of that car coming there, do we need to look for another step forward at that kind of technology, or focus on what we're doing and continue with that? So something I've got to think about. And around things like chassis, powertrain, we're very much at the limit of what we've got right now. So do we need to go and make a step to go and, I think we can get everything so it will just about scrape a sub 8 minute run, but everything's going to be perfect. So sometimes it's better to guarantee a success by making a 7.5 minute car and driving that slowly. So yeah, we'll see that.
I guess the danger is always in making a really significant large step forward, or what should be a large step forward, and then finding that it produces a whole bunch of unforeseen side effects that you need to kind of work your way through as well. So again, with limited testing and availability of the mountain resources, that's always something I guess you have to have in the back of your mind, correct?
I think so, yeah. I think that's why we'd sort of parallel path it. So we'd keep, we've got the upgrade package for the Wolf and right now, and get that sort of dialed in where that needs to be anyway. And then we could maybe look at doing a new car on top of that. So that's how we'd get rid of that risk, maybe.
Okay. Moving on, the next question. And I mean, your career is fairly unique in terms of an automotive engineer and a race driver. So I'm not quite sure how to angle this specifically, or how you want to angle your answer, but basically, if you had some advice that you could give to a younger version of yourself to maybe fast track and get you where you've got to in your career, what would that advice be? So you can angle this in terms of race driving, automotive engineering, or perhaps both, whatever you prefer.
I think from the racing side of things is really pay attention to how you present yourself. It's something that I was always focused on, just being fast and less so on, presentation and things like that. And that does make a big difference. At the end of the day, motorsport is professional at the level we're at, and you're marketing products and companies. And so it's very important how you present yourself. So, and also social media of having people following your story and properly telling your story. I have a great story and I'm not great at telling it. And so all those things are important to go and succeed in that world, because that's, it is an entertainment and marketing world. That's what motorsport is. So definitely presented myself okay, but not as well as I could. And, as an engineer, I tend towards making my car faster with my brain rather than actually presenting myself better and getting better partners on board and then a bit more budget to go and increase my performance. Both valid ways of going and doing it. So I think I'd say that to myself. I think the other thing would be is like, be patient and keep chipping away and trust in the process. I think this stuff takes time. It takes a lot of time, effort, work, blood, sweat, tears. But if you keep succeeding, keep doing a good job, and also enjoy what you're doing, then the success will come.
And I think that last point you made there, if you enjoy what you're doing, success will come. I mean, it is really important to continue doing something you're enjoying doing. So if it sort of gets to a point where it's becoming a chore or you're not enjoying it anymore, I think that's often a sign to maybe take a step back and reassess your direction or what's going on. And in terms of the race driving thing, I think the media side of things is really, really important and so often overlooked. You do need to be able to sell yourself to your sponsors, and in turn, if you're an ambassador for that sponsor or their product, that they want a likable, sort of well-spoken person to be the face of their brand. So really, really important advice there. Last question for today, Robin. If people want to follow you and see what you're up to, maybe follow your journey for the 2023 Pikes Peak, where are they best to do so?
We've got, first of all, the Sendy Club, which is Sendy, the Sendy Club. And that's Instagram and YouTube, actually, the best place to follow that. And then me, myself, personally, is Robin.Shute, which is Shute, and that's on Instagram. It's probably the best place you can go.
Okay, perfect. We'll, as usual, put a link to those accounts in the show notes as well. Make it really easy for people to find those. Look, great chat there, Robin. Do appreciate your time, and it is great to get some insight. I must admit, this year I was a little bit jealous, a bit of FOMO there, not being able to be on the mountain, although I did enjoy not having to get up at 3 a.m. as well. So we'll leave that to you guys. Maybe the HPA crew might make it across next year, and we'll pray for some fine weather and see what the car can actually do given a clean run.
I'd love that. Yeah, missed you guys. It'd be great to have you back on the mountain.
If you enjoyed this episode of Tuned In with Robin Shute, we'd love it if you could drop us a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that helps us in turn to continue to get bigger and better guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt anywhere in the world. This is a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to SRS13, who said some real interesting tidbits of info here. Love being able to listen to these in the car when I don't have time to sit down and watch the videos. Thanks for your feedback there. Great to hear that the podcast is hitting the mark. Get in touch with your size and shipping details, and we'll fire off a fresh tee straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school, and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get 75 $75 off the purchase of your first course. You'll find our full course list at hpaacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpaacademy.com/courses.